One common misconception about technology and warfare is that some people see technology as an isolated force multiplier that just wins or loses wars. Yet if one takes a closer look at technology, it becomes rather apparent how it is almost impossible to identify it as an isolated entity at all, because it's very dependent on a wide range of factors that allow or inhibit its implementation in many ways. To name some of these factors, the state of technology is entangled with industrial capacity. Yet even with a strong industry, the successful integration of new weapons is dependent on the culture, leadership and doctrine, as seen in the Franco-Prussian War of 1870 to 1871. Additionally, the successful use of various weapon systems is also dependent on administration and logistics, as examples from medieval siege weapons indicate. Furthermore, some technologies like tank and aircraft without proper organization and information processing had a limited effectiveness on the battlefield, as the stark differences in the effectiveness between tanks and aircraft in the two world wars clearly show. At first, let's look at the integration of technology in military terms. The Prussians in 1866 kicked the Austrians at the Battle of Königsgrätz quite severely. The reasons were several, but the key distinction was that the Prussians used the Zündnadelgewehr, the needle gun, a breech-loading weapon, whereas the Austrians still used a muzzle-loading weapon. As a result, the Prussian could fire far more shots at the Austrians and thus easily gain fire superiority, which unsurprisingly resulted in a major disbalance on the battlefield. Prussian units facing anywhere from 2 to 10 times their number routinely bat back Austrian advances or successfully pressed the attack. This is also clearly reflected by the losses at the Battle of Königsgrätz, where the Austrians lost almost 5 times more than the Prussians, namely 41,500 Austrians versus 8,800 Prussians. Now if one applies the technology wins war perspective here, giving the Austrians a better gun should have corrected this issue. Although we don't have another war between Austria and Prussia in that period, we have a similar one, where the side opposing the Prussians actually had a better gun and various other benefits that Austria lacked. Now who was this enemy? The French, and the conflict was the Franco-Prussian War. France did not have to face the same economic constraints as Austria. In fact, in August 1866 the French army adopted the chassepot, a rifled breech loader with longer range, higher rate of fire and more reliable firing mechanism than the Dreisel needle gun. The French army entered the 1870 to 1871 war with nearly 1 million shoulder arms that were superior to those the German soldiers carried. Now in case you don't know, the Prussians and other German states bet the French, and to add insult to injury declared the German Empire in Versailles in 1871. Yet how is this possible that the French lost if they had a clearly superior rifle in sufficient numbers? Well, the French difficulties were entirely doctrinal, or more precisely in the execution of the doctrine. Despite the chassepot, French tactical doctrine was confused. Regardless, French troops did not receive adequate training with the new rifles to use them effectively. In other words, there's a clear difference between equipping your riflemen with a proper weapon and using your formations effectively along the issued equipment. Note that in both wars there were several factors crucial for the Prussian victories. In this video I merely discuss a tactical one, as I talk about other changes in this video on my second channel. Anyway, such problems were of course not limited to the 19th century. Yet the asymmetry between mentality and technology becomes even greater with large-scale weapons exports, which can easily lead to an underestimation of weapon systems. Though Soviet equipment and doctrine had been widely exported, it should be explicitly noted that no third world country has developed the expertise to exercise and orchestrate Soviet operational practice. Many such countries have gained political advantage by holding large tank inventories. Militarily, however, few have done more than drive these vehicles about. Now, another interesting example is about the mentality of the military leadership and the goals of the industry. Germany during the Second World War is not particularly well known for its mortars, although mortars were a rather simple, mobile and effective weapon. Their use in the Wehrmacht was limited. Since for close support weapons they mostly relied on Infanteriegeschütze, infantry guns. This was probably due to the mentality of the officers and the benefits for the industry, since such a gun was way more complicated and expensive than a simple mortar. The Wehrmacht focused too long on the use of infantry guns, but their production and use was considerably more expensive without being able to significantly exceed the effectiveness of mortars. The interest of the influential traditional gun factories of the German armament industry may have met with the immobility of military personnel, who were biased in the scheme of a disciplined and tight-knit deployment of gun batteries. Now let's look at the crucial connection between industry, research and development. A few people commented on how wars are won, a simple model video, that I didn't include technology as an explicit factor, which they considered an oversight or a mistake. Yet I mentioned industry, which for me includes the state of technology and research, since technology doesn't exist in a vacuum. Nor can research be properly performed without a large and extensive infrastructure of production and information processing facilities. What do I mean by this? Improvement in technology and engineering are usually performed in small steps, since they require constant refinement in various areas. Let's take as an example engine development. For instance, you want to increase the efficiency, and to do so you need to optimize clearance design. This requires that your high-end measuring tools in your laboratory are able to measure the difference. Additionally, your measuring tools in your production facilities need to be able to measure it as well. And of course you need the proper production equipment to reach this precision. This usually also requires proper training of the workforce and adapting various production processes. Thus any improvement will probably be gradual since so many factors need to be accounted for. Now this is even a major issue during peacetime, when equipment, resources and specialists can usually be basically bought. Yet once you bring a war into the equation, it becomes more complicated, and since I mentioned complicated, let's talk about Germany again, which built various high quality weapons prior to the Second World War. Yet during the war, their industries often suffered due to limited capacities to produce replacements in large numbers. This was due to various factors, some of them were the lack of standardization of types, limited production capabilities and unwillingness to adapt the production methods. For instance, Germany only had one tank factory in the whole war that used manufacturing belts, the Nibelungenwerke near Linz in Austria. Now the reasons for the lack of manufacturing belts are various. The Waffenamt, Army Weapons Agency, originally opted against manufacturing belts in order to allow for sudden changes in the production, whereas the companies involved mainly faced a severe lack in machine tools and production facilities during the war, and thus were unable to upgrade their existing facilities. Similarly, the reasons for the lack of panzers that were powered by diesel engines are related. Although there were several reasons why Germany didn't have a panzer with a diesel engine in the early stages of the war, in the late war the main factor was simply there was no large supply of such engines, since the major supplier for tank engines in Germany only produced petrol engines. Yet these are just basic limitations that every country faces in one way or another. If you take into account the geopolitical situation, it becomes even more complicated. For instance, in some cases various advancements are not possible due to the lack of resources. For instance, Germany in the Second World War lacked heat-resistant materials, which were crucial for producing jet engines. As a result, they needed to research and test various metal alloys first. Thus, the access to strategic resources is also a crucial element among many others. In short, an isolated view on technology, which is independent from the current state of industry, makes little sense. Remember, this isn't Terraria where you can go from a wooden hammer to a machine gun in a few hours. Our technological achievements build upon a huge infrastructure of existing industry, access to raw materials, measuring equipment, laboratories, universities, and codified experience in the form of books, and lately also digital documents. The latter allow for an almost instant transfer and exchange of knowledge, which hugely increased technological advances in the last years. Yet never forget the whole infrastructure which it sits upon. Now the next major aspects are logistics and administration. This is basically an analogy to an army walks on its stomach. Even if your industry can put out a large number of good weapons and your army is properly trained to use them, you also need to administer and supply them. This was always an issue, yet in the Middle Ages, when literacy was rather low, food conservation and the infrastructure limited, it was a different kind of challenge than nowadays. Thus, proper administration was a crucial aspect in being able to deploy weapons on the battlefield. Bradbury notes about provisioning of supplies in medieval times. Ability in this area explains the military success of some rulers who may not have been great generals. Philip August comes to mind. Or a more specific example about the 100 Years' War. All this argues against overestimating the role of technology in the expulsion of the English during the 100 Years' War. Nothing in the sources from either side suggests that the French guns were qualitatively different or technologically advanced. French success in war clearly owes much to the French artillery, but it may not have been so very different from pieces available on the market virtually anywhere in Western Europe. All assumes that the success was likely to the administrative approaches. The French probably built their victory more on administrative and logistical efforts than on technological advances. In building up a reliable siege train beginning in 1440s, the Brothers Bureau might well have sought to avoid technological novelty in favor of more established and conventional forms of guns. Yes, as bleak as this sounds, bean counters can also win wars. So after this rather depressing statement, let's move to a more refreshing topic, namely organization. Since the best weapon system without proper organization is just a dull blade, and one of the best examples in this area are panzer divisions. Although the British had the early lead, all they managed to come up with was something called armored division, a pure armored formation with hundreds of tanks and almost no supporting arms. Designed for speed and dash, it proved to be a disaster in the early years of the war. Meanwhile, the French had two different approaches. One didn't have enough punch and the other was just too slow. First, the Germans came up with the Panzer Division, which included all supporting arms like infantry, artillery, recon, supply and engineers, as organic units that could move as fast as the tank, hence combining both a sufficient amount of firepower and maneuver. Which brings us to the next point, since organization is highly dependent on proper forms of communication and information processing. While the Panzer Division was clearly a successful form of organization, without proper coordination and communication capabilities, it wouldn't have worked at all. Although most people are all in awe of panzers and Stuckers, what really gave them the edge was a rather mundane type of technology most people don't talk about at all, the radio. Though hardly recognized at the time amidst all the hub about tanks, whose strengths and weaknesses were the obsession of most contemporary armies, radio was the real breakthrough of the period. The days of the runner, the unreliable telegraph and Morse codes were over, replaced by direct voice messages from the commanders to subordinate, and vice versa. Similarly, the radio also had a major influence on another German World War weapon, the U-boat. In the First World War, the switch from the Allies to a convoy system reduced the success of the German U-boat Waffe significantly. Yet it was not possible to coordinate and concentrate U-boats into wolf packs like in the Second World War, since the capabilities of radios were still rather limited. Additionally, they were also not compact enough. Now if we return to the initial graphic, I hope you can clearly see now how it makes more sense, and that technology is an extremely abstract concept that, although sometimes is presented as this all-determining factor, it is more of a very obscure element that can hardly be removed from a large number of physical factors like industry, infrastructure, nor from social factors like mentality or administrative aspects like organization and logistics. Well, that's about it. If you like this content, consider supporting me on Patreon. Remember, every single dollar helps. Special thanks to Justin for providing some crucial resources here. And if you want to learn more about crucial interdependencies, check out my World War Management 101 video, or why Rommel is so complicated. As always, sources are linked in the description. Thank you for watching and see you next time.